Hey, Mr. Doty here. Here's a brief walkthrough video of the two strategies for multiplication and the two strategies for division that we've learned so far this year. First is the area model. It's a way of representing a multiplication problem as a length and a width. And we decompose that length and width into smaller numbers so that we can find partial products, add the partial products together, and then find our total product. So our first expression is 76 times 23. I don't know 76 times 23, but I do know how to multiply numbers that end in 0. So I'm going to decompose 76 as 70 plus 6. And I'm going to separate my area into two parts now. I have a part that represents 70 and a part that represents 6. Again, I'm going to decompose my width. So the same way that I decomposed 76 by place value, I often want to decompose my width by place value. So 23, I could decompose as 20 plus 3. And I'm going to draw a line across to do that. Okay, my next step is to label all the sides so that I don't get confused, so that I multiply the right lengths and widths together, because I want to find 4 areas and then add those 4 areas together. So to find this side length from here to here, I'm going to look above. So if this side length is 70, I can label across with the same number. So 70 is on top and 70 is on bottom. Next, I have to label the right side of my rectangle, my area. And if the left side was 3, the right side will be 3. And same as before, if this section is 20, then so will this section be. Okay, I've labeled all my sides. They're all reasonable numbers. So the large numbers represent the large area. The smaller numbers represent the smaller area. And I'm going to write the equation for each of these rectangles. So here's my length, 70, my width, 20. So my equation will be 20 times 70. And I know that I can use my math fact knowledge. So 7 times 2 is 14. But this factor is 10 times bigger, which would make a product 10 times bigger. And this factor is also 10 times bigger, which would make this product 10 times bigger. So my answer is 1,400 for this partial product. My next partial product, I can go in any of these 3 boxes. I'm going to go with the 6 times 20. I'm going to go a little bit quicker through this. So 6 times 20 would be 120. And 70 times 3 is 210. Last box, 6 times 3, length times width, equals 18. Okay, I'm going to add up my 4 partial products. 1,400, 120, 210, and 18. And my sum will be 1,748. So this is probably the most comfortable strategy for most of our 4th graders, but we're trying to wean them onto using something that looks more like the standard algorithm. And the way that we're doing that is something called partial products. So I'm going to multiply the same way that I would in the standard algorithm, my ones place times my ones place, my ones times my tens times my ones, and finally my tens times my tens. The only difference being, instead of regrouping with the numbers up here, as most adults would do, we're actually going to represent that as 4 partial products, very similar to our area model. So here's what that means. First, I multiply my ones place times my ones place. So that would be 3 times 6. As you can see, this correlates perfectly to the area model. Next, I'm going to multiply my ones place times my tens place. So that would be a 3 times 70. Okay. So 3 times 70, I know 3 times 7 is 21, but it's 10 times bigger in that relationship, so my answer is 210. Next would be my tens place, so 20 times my ones place, 6. So 2 times 6 is 12, but again, that factor is 10 times bigger, so I'm going to add an extra 0 to represent 10 times bigger. Finally, my last relationship is 20 times 70. So if you're looking across the screen to the left, you'll notice all four of these partial products correspond. I have a 1,400, I have a 120, I have a 210, and I have an 18. Okay, so again, I would add up these four numbers. I can add them in any order. Our students know that we can add what's called an addend. Each of these are addends in any particular order, and we'll still get the same result. And sure enough, we still get 1,748. All right, so those are our two primary strategies right now for multiplication. In division, our fourth graders come in from their third grade experience knowing the circles method. So the idea is to put the same number in each of these groups until we've exhausted this quotient to 0, and then we look to see if there's a remainder. Okay, so what does that mean? I'm thinking of groups, big groups, maybe 50s, so 50, 50, 50, 50, and I ask myself, do I have that much in my I might have called that a quotient just now. This is my dividend. So do I have enough in my dividend to put 50 into each group? So if I tried that, 50, 50, 50, 50, no, I don't have 200 to give away. Well, could I go a little bit smaller? Could I think about maybe groups of 40 or 30 or 20 or 10? So I'm going to start with groups of 40 because I know 40, 80, 120, and 160, because I know multiples of 4 are like multiples of 40. Okay, so I'm going to have to subtract that amount away from my dividend. So that's 160. 40, 40, 40, 40. It's 160, which leaves me 22 left. So I still need to divide 22 into 4 groups. So I might go with, 5, 10, 15, 20. And I still have a few left over. Now I can't put 1 in each because that would cost me 4. I can't put anything more than 1 in because my remainder is less than my divisor. And our students know that when our remainder is less than our divisor, we're done dividing. So our answer would be, I'm going to add up all the parts in just one of these groups, 45 with a remainder of 2. So that would be our answer, 45, remainder of 2. And our students know how we could check this. We could multiply 45 times 4, and then we could add those 2 left over. Now, the newest thing for many of our fourth graders is being fluent with our Big 7 strategy. It's also known as partial quotients because the same way that we were adding in parts, we're now dividing in parts. And here's how that works. I want to know how many multiples of 4 I could subtract out of 182. So maybe 10 multiples of 4, well, that would give me 40 to subtract. Well, that's not very much of a change. Could I do 100 groups of 4? Well, no, 100 groups of 4, or 100 multiples of 4, that would be 400. Well, maybe I could look into 50s. No, again, 4 groups of 50 or 4 multiples of 50, that's still not going to cut it. I'm going too big. So maybe I'm going to go 40s again. 40 multiples of 4. 40 multiples of 4, and I know 4 times 4 is 16, but 10 times bigger would mean we put a 0 in the ones place. I'm left with 22, and I'm going to group it a little bit differently than last time. Let's say I know 3 groups of 4 is 12. And again, whatever I put in here, that relates back to this first piece. So really, instead of drawing 4 groups, I just draw 1 group knowing that it represents all 4. Left with 10, and I could do 2 more. So 4 times 2 is 8. And I have a remainder that's less than my divisor, so I know that I'm done. Okay, so I'm going to add up my partial quotients. That's 45, remainder 2. I hope this video was helpful. Sorry it was kind of long. It takes a long time to talk about this stuff. These are all things that you should see coming home or see on Seesaw, and I hope you like it. We will get to the traditional algorithms as well this year, all in good time. Hope you're having a great day. Bye-bye.